Hello students, welcome to Unit 1 Notes Section 1.5. At this time you can pause this warm-up and try it on your own. In a couple of seconds I'm going to actually complete it quickly by hand. Alright, so let's begin. What is the absolute value of these expressions? Well, it's the true value. So we are going to find the absolute value of negative 6, which is 6. The absolute value or true value of 3.5 is 3.5. The absolute value of 7 minus 10. Be careful, do this math first. It is not equal to the absolute value of 3. It's actually equal to the absolute value of negative 3 first. Do the math out, then find the true value 3. All right, negative 4 minus 2 is actually negative 6. That's why it's important to combine them first. Because if you start making them positive and changing what they are, you're not going to get the right result. And then the absolute value then is 6. Okay, so let's see. We get 6, we get 3.5. Yikes. Okay, this isn't working the way I wanted it to. I'm just going to put a box around it. 3.5. There we go. 3. This one is 6. Here we have, this one's a little bit difficult. It's going to be negative 2 plus 4. So it's the absolute value of 2. Don't forget, a negative, you got to do that work first. Because we're applying a negative to another negative. So it becomes a positive. So the absolute value of 2 is 2. All right, and the last one is going to be the absolute value of 9, which is 9. All right, and so now we got a few of these. Solve the expression. So let's combine like terms. We get 3x minus 6 equals 6. Add 6 to both sides. You guys are masters at this. I know you are. So I'm going to solve it quickly, and I get the answer 4. Feel free to pause. I'm just trying to save time. Again, we can evaluate that if we want to know if we got the right answer. Okay, we are going to combine these, so we get 8x plus 9 equals 81. Take away 9 from both sides. We get 72. So x equals 9. Again, feel free to pause. You can catch up with the work, okay? Just again, trying to save time. And here it looks like my easiest solution will be to move w over. So I get negative 2 equals negative 4 plus 6w plus 4 plus 4. 2 equals 6w divided by 6. W equals 2/6, which is actually 1/3. All right, yeah, I got a fraction for that one. I'm going to check real quick. Let's see, 7/3. 7/3 is 2 1/3, so take away 4. Yep, that works out. Okay. So what are we going to learn? This lesson, we are going to learn about segments and ones that are congruent. We're going to learn a little bit about midpoint, focus a little bit on midpoint, congruent segments, coordinates, and finding lengths of it. So here's your first introduction to congruence. What is congruence? Well, it kind of looks like an equal symbol, But what it says is, it says that all parts are also similar. So not only are they just similar, but they are also equal, making them congruent. So that symbol, what it's saying is that here I have 2 centimeters. AB is 2 centimeters long. I also have CD, which is 2 centimeters long. They are equal to one another in length, which means that they are congruent. And look at tick marks. Here you see some tick marks. These, they're also called hash marks or hashtags. No, hash marks. Um, and I can't think off the top of my head. They have different names, but I always call them tick marks. So what they mean is, what you're saying is, these two things are the same, but I don't know what they actually are. So for instance, 2 students in class stand near each other and they are the same height. That's great. We don't know what their height is. We don't have a tape measure with us at the moment, but we know that they're the same height. It's a visual. So that is what congruence is. It's saying it another way without having specifics about it. So AB equals CD is what we say is equal, and AB congruent to CD is congruence. Notice the difference. AB has a hat on, CD has a hat on when we use congruence. So whenever you're using that symbol, think about the congruent part is above the equal sign anyway. You're also going to include it, the hat on AB and CD. Now, when you're talking about equality, you're just going to do just the same. When you normally say x equals 4, well, AB equals 2. So it has no hat on it. You're filling in the blank for the length of that segment. Okay? So what I can do is I can do an extended equality here. AB equals CD equals 2 centimeters. All right? So that's congruence. Make sure you use the hat. That's equality. You don't need the hat. It's actually wrong if you use the hat when you're talking about equality. So here is our next postulate. This is an accepted statement of fact. AB plus BC equals AC. As long as this line is collinear, and as long as as long as B falls in between C and D. Okay, so what does that mean? B is in between C and D. That means that if you add this and this together, let's say AB is 3 and BC is 2, I would say to you, how long is this total length? I would say, well, it's 5. Okay. Yep, that's true because AB 3 plus BC 2 is equal to AC, which is 5. Segment addition postulate. Pretty easy. Just add them together, set, and they are equal to the total. When you have a midpoint, that's when it's in the middle. What that means is that in this case, we have AB and CD. I don't know the length of AB. Let's call it 5. I don't know the length of BC. We'll have to call it 5. What I do know about AB and BC is that they are equal to one another. Oops. So we can say that they are equal because they are congruent, because B is a midpoint of AC. Notice there's one tick mark. It doesn't matter how many tick marks you use. That's a question I get all the time. It doesn't matter. Okay. So what I do want to make sure I do is make sure that if I use one tick mark, I'm marking the things that are congruent. And when I use 2 tick marks, I'm marking the things congruent. But it doesn't matter how many tick marks you use. You can use 5 if you want, as long as all the 5s match up with all the other 5s, and all the 2s match up with all the 2s, and all the 3 tick marks match up with all the 3s. Use as many as you want, or as few as you want. Okay. Okay, so what you would do here is you would set them equal. So if I had, for instance, x here, and I had x plus 1, you could set them equal and solve. Well, that one's not. You can't set that equal and solve because it won't work. But you get what I'm saying. You can just add them. We'll do examples with it. Okay? So let's get through these questions. I think we'll be pretty quick. All right. Find AB and BC. So be careful when you're doing this one. AB is not one, is not 2 away. It's 1, 2, 3 away. Well, let's see how far away BC is. 1, 2, 3 away. Not 4, not 2, but 3. Okay, CD. 1, 2. DE. 1, 2. Okay. Find AB. AB is equal to 3. BC is equal to 3. So AB equals BC equals 3. So therefore, we can say AB is congruent to BC with the hats on. Okay? Compare CD and DE. Are the segments congruent? Literally the same question. And yes, CD equals 2. DE equals 2. So CD equals DE equals 2. So CD, oops. So CD is congruent to DE. We are done with that one. To find AD, in example 1, suppose you subtract -8 from 5. Do you get the same result? Why or why not? And the answer is yes, we do. We're going to do -8 minus -5. What's a negative minus a negative? It's a positive. And so what's -8 plus 5? It's -3. But wait a minute, distance can't be negative, right? So what I had to have done with this one is be sure that I include absolute value, and that's why we did this for our warm-up, because now I can say the absolute value of -3 is a positive 3. And so the answer to this is yes. Do you get the same result? And I do. I get 3. All right. I'll just put a little note here. Distance is positive. All right. Next one, using the segment addition postulate. So here it's saying that if I were to do ds plus st, wait a minute, let me keep the colors consistent. So ds plus st is going to be equal to dt. dt is 60, ds is 2x plus 8, and st is 3x plus 12. So I'm going to underline that first. And I will do ds, which is 2x minus 8, plus st, which is 3x plus 12, 3x minus 12, is equal to dt, which is 60. And what I did was I used the segment addition postulate and I used substitution to put it all together. So now I'm going to just combine it. So I'm going to have 2x minus 8 plus 3x minus 12 equals 60. I'm going to combine like terms. 5x, take away 20, equals 60. Add 20. Five x minus 20 equals 60. Let me just make sure I do my math right up until now. Minus 20. Yep. Okay. So add 20. I get 5x equals 80 divided by 5. X equals 16. All right. X is equal to 16. Feel free to pause the video if I went too fast or rewind, okay? And there we go. X is 16. But that wasn't the question. That wasn't the whole question. It said what is the value of X? Find it. It also says find ds and st. Okay, we can do that. I'm going to do ds and st over here. So ds equals 2x minus 8. ds equals 2 times x has a value of 16. Whoa. Whoa. Has a value of 16. So ds equals 32, take away 8. ds equals 24. All right, the next one, st. Oops, wrong color blue. st equals 3x minus 12. st equals 3 times 16 minus 12. st equals 30 and 18 is 48. Take away 12. st equals 36. Nice. And guess what? What is 36 plus 24? 36 plus 24 is 60, which is the value when added together. It is the value of dt, which is 60. All right, so that is good. We're good to go with that one. Okay. Here we have the same thing happening with EF and FG. I'm going to write out the work, and I'm going to try to save some time here. So I'm not going to color code it. I'm just going to say I'm just going to go get straight to the point and do this out, but do it on your own. And then when you're done, compare it with what I have, okay? And if you get the same thing, you did it right. Oops. If you did the same thing and you get it right, then you're good to move on, okay? All right, 6x, 30 minus 20 is 10. You know what? I'll write that step out. Oops. I'm just going to break it out of its parentheses because they're not needed. Okay, combine like terms. Subtract. And divide, and we get x is 15. So, all right, now I'm going to color code them. So EF equals 4x minus 20. EF equals 16 minus 20. EF equals 40. Okay. And lastly, FG. So listen, if this whole thing's 100 and that one's 40, what's left over? And the answer, yeah, is 60. So I should have 60 left over. So if I did everything right, I should get 60. So 2 times 15 plus 30. FG is 30 plus 30. I'm writing too fast. All right, and FG is equal to 60. And we are done. 1640 is 100. Nice work. Hopefully you got this. You can always ask questions on it. Pause the video because I went super fast. But there it all is for you. All right. Using the midpoint. I think this is our last couple of examples before the homework. Yep. So the midpoint, here's what we don't do. We don't do AC plus CB equals AB. Because, well, we don't really need to because they didn't give me AB, right? I have no idea what AB is in length. What I do know is that C is the midpoint. And what that means is equals. So what we're going to do is we are not going to set it up this way. We're actually going to set up like this. AC equals CB. All right. And with AC, I'm going to put in 2x plus 1, and that's equal to CB, which is 3x plus 4, minus 4. And then we just solve from here. So I'm going to take away 2x, get 1 equals, okay, it's doing it again. Okay, 1 equals x minus 4. Add 4, add 4, x is equal to 5. All right, so we want to find AC, CB, and AB. Whoa, okay, so AC is 2x plus 1. AC is going to be 2 times 5 plus 1. AC is equal to 10 plus 1. AC is equal to 11. Okay, that's AC. CB is 3x minus 4. CB equals 3 times 5 minus 4. CB equals 15 minus 4. CB equals 11. Well, that's cool. AC and CB are equal. Well, they have to be because it's a midpoint. So we should have gotten two values that were equal to one another. And so now I'm going to use I'm going to say, now I am going to say that AC plus AB AC plus CB equals AB. So what I'm saying here is that AC, this part, plus CB, this part, is equal to the whole thing, this part. And by saying that, I now am going to use substitution to solve for AB. No, I'll rearrange it. No, that's fine. Okay. So 11 plus 11 equals AB. So AB equals 22. And we are done. So you use the segment addition postulate and substitution to substitute in the parts that I knew. Okay. All right. Z is the midpoint of this, and XY is 27. So let's draw this out. Z is the midpoint of XY. So let's draw XY. Let's throw a Z somewhere in the middle. Not drawn to scale, you know, let's do our best, but we're not perfect. Let's see. That's definitely not perfect. Looks a little better. I'm going to throw in this tick mark. I'm going to say that this is Z. And what I do know is that XY, which is this part, XY is 27. It wants me to find XZ. Well, if this is a midpoint, guess what? This is half, and this is half. So I just need to do 27 divided by 2. 27 divided by 2 is this half, and 27 over 2 is this half. So I can say that XZ is equal to 27 over 2. And if we need, or if we want to write it as a decimal, XZ is equal to 13.5, which is literally half of 27. Whoops. And that's it. So you are already at your notes. I know it went fast, trying to keep these videos short. Ask any questions you have in class. Also, feel free to start 1 or 2 problems just for practice, and then the rest we're doing in class practice. And it's due tomorrow, okay? All right, good luck.